Hello everyone, my name is Satyanto Krido from IPB University. Today I'd like to present our paper entitled "The Quantification of Water Balance in Terrace Body Field in Northern Bali by Using Remote Monitoring System," prepared by IPB University Research Institute of Humidity and Nature, and also Kyushu University, Japan. This research is about integrated water and land management in the terraced paddy field in Northern Bali. We'd like to quantify the water balance using the Internet of Things-based remote monitoring system. We saw that there were importance of understanding traditional subak water management system in modern time, in this case by continuous measurement. This project was collaboration between IPB University and Research Institute for Humanity and Nature and under C9 designing local frameworks for integrated water resource management project, which were actually ended 2015, and this is actually our late publication of our activity. So the location of our observation is the midstream of Sabah watershed, Northern Bali. And the tools we use is mainly the remote monitoring system for environmental parameters, and we use it to acquire data of soil moisture, rainfall, evapotranspiration, water level, etc. And this is our location. This is our watershed, and this is our location. And if we zoom out, we can see the terrace image. And this is our field with area of 300 meters square, and this area known average yield is 4.5 ton per hectares. We set up three remote monitoring system stations to observe weather, water, soil, and field images. And this is our system: the weather station, the soil monitoring system, and the cloud surfer. And we acquired rainfall, solar radiation, air temperature, relative humidity, wind speed, air pressures, evapotranspiration, soil water content, soil electroconductivity, soil temperature, also water level, which are quite required to estimate the water level, water balance at the field. Using this uh, approach, we previously published to obtain the water balance, including the net water discharge to the field, evapotranspiration from the field, percolation from the field change in water storage, and also rainfall at the field. And then we calculate the water productivity, which are the amount of yield produced by unit of volume of water. That indicates how effective is water being used for rice production, for instance. And it can be calculated by using evapotranspiration, net discharge, or net discharge combined with rainfall. And we got the result of water balance component, including rainfall, net discharge, percolation, evapotranspiration, and field water storage changes. And also we calculated the productivity using different metrics, and we found the challenge of shifting dry and wet season and their impact to the cropping patterns. These are images we got from the field, and we tried to accumulate the rainfall, and we model using a fifth order polynomial equations, which with which we use the derivation to determine the the start of dry and start of rainy season. It's dry. And so we overlay the information with the matrix of cropping pattern agreement by the Subak, and we can see this. There was a shifting of dry and wet season, and also we can see the shifting of cropping pattern. And in this case, the best data we could get for calculation is the last season. And using the data, we calculate the water balance. We calculate the water productivity of the field, and it's about 0.9, 0.23, and 0.154 80 base, Q base, and Q per rainfall, which are actually much more than reference found elsewhere. Then maybe the water productivity of the field can still be increased if water limiting practices are possible for the field. And we try to identify the annual water balance of the field. The total annual water balance for the site, as if you compare the rainfall, is much lower than the net discharge at the field. It's 2,200 versus 7,000. And for the component of water balance, most of the component goes to percolation, which might be due to terrace condition. Based on the result, we understand the water management patterns and their effectiveness, and the influence of terrace fields on water flow and seepage. And we found the potential of increased water productivity through improved practices. As a conclusion, we found there were variability in cropping patterns due to environmental and management factors, and there were significant water loss through the percolation and seepage, probably due to the terrace structures. And there's still uncertainty about the water loss at is it becoming the groundwater recharge or being reused downstream. Thank you very much for your attention.